From the beautiful South Studios of Way Happy, this is Mr. Myron 1.5, Properties of Exponents. Now, exponents are fun, but they're tricky, so be careful. You've been working with them since 6th grade, and they can still sneak up, and that's why we talk about them. So let's see what we got. You know that powers, really, right? Powers have a base. They have this thing down here, which, oh my goodness. They have this, which is called a base. And they have this, which is called an exponent. And that just tells you how many times to write that base. That's all it is. Now, be careful. The exponent belongs to the number, and sometimes that can be tricky, as you can see right here, where the base was just the x, not the negative or the 2. And so be super careful when you see something like that. In fact, when people write something like negative 2 to the third even, that means negative 1 times 2 times 2 times 2. This is the 2 to the third part, right? And so the negative was not included in there. If they wanted to, they would have written it like this. And then that would be negative 2 times negative 2 times negative 2. So be super careful if the negative is included or not, or if the number out front is included or not. A lot of people see 3xy squared, and they think the squared belongs to everything, but it actually only belongs to the y. So be super careful and deal with your exponents, and life will be good. All right, let's look at example 1. Write it in expanded form. So this is exactly what it is. So A, can you expand that out for me? Sure, it's 5z. And then I have 2 of those, so 5z. Now, I'm tempted to multiply it together, but they wanted expanded form, so I stop. And that is all it is. You can see B, I forgot to erase the answer there, but you can see that it was a negative 1 times an s, 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 s. That's really how I would write it, negative 1, and then there was 4 s's. Or what about the last one, C, kind of the trickiest of the group? But I go ahead and I see a 3, and then I see an H, and an H, and an H. And then I see a K plus 3 twice. So I put little dots in there so you can see them all. But that's everything that's in that problem, part C. All right, what about some properties of exponents, right? Or zero and negative properties of exponents. Anything to the 0 power is 1. Easy, anything. I mean, you take my name, Meyer, and you raise it to the 0 power, that's going to be 1, no matter what you have. Anything to the 0 power, always 1. Negative exponents are a little trickier. A negative exponent means, move me in the fraction that I am in. So if you have like 3 to the negative 2, that's the same thing as 3 to the negative 2 over 1, which negative exponents mean move me. So there's nothing up top, so I got to keep a placeholder. But that 3 to the 2, if I move it to the bottom, if I take this and I move it down, then the negative exponent disappears. So that's 1/9. Now be careful, because what if we have 2xy to the negative 4 over z to the negative 2, something like that? That negative 4 only belongs to the y. So you'll have 2x, and then the y to the 4th would go down. And oh no, this z squared would go up. So it'd be like this, z squared. So notice that 4 did not belong to the 2 or the x. It just belonged to the y. The negative mean move me down. And then down below we had a negative that moved it up. All right, what are we going to do with these exponents then? So if I go, I lost my screen there. There you go. If you have a, which is 3 to the negative 2, then that means, that's what I did, unfortunately. So 3 to the negative 2 over 1, which is then move me. I can need a placeholder, 3 to the 2, which is 1/9. And there you go. And what about B here? I have 2/3 to the negative 2. So remember, that exponent belongs to both of them. So that's 2 to the negative 2 over 3 to the negative 2. And then you're like, oh my gosh, they both got to move. The 3's got to come up. The 2's got to go down. Oh my goodness, that's going to be 9 over 4. And you jump up and down and have your answer. All right, there's a lot of exponents there. Let me ask you a question, and I'll be right back with some properties. All right, beautiful work. Now let's talk about those properties of exponents that I was promising you earlier. Now you can see there's 5 of them there. So let's just make sure that we kind of understand what we got in these different properties. So when you have things that have the same base, right? So if you have, a 3 squared times a 3 to the 5th, if they have the same base, then all you do is keep that base, if it would write, and add the exponents together. So that would be 3 to the 7th power. So if they have the same base, you keep that base and you add their exponents together. All right, what about the quotient property that says, all right, if you have two things, let's do a negative number this time, negative 2 to the 4th over negative 2 to the, let's say, 6th. If you have the same base, then all you do again is you keep that base because that's a winner, but you subtract the exponents. So that would be negative 2 to the negative 2. Oh my gosh, and negative means move me down. We just learned that. So that's 1 over negative 2 squared, or 1 over 4 would look a lot prettier there. All right, so if you have a division problem and they have the same base, you can subtract their exponents. All right, what if you only have one, kind of back to that first one, the one that feels like the power property, but it's not, it's the power of a power. The other one was the product of a power. So say you have, negative 2 to the 5th power, and then I want to raise that to the 3rd power. Notice the base is only written once, where up here the base was written twice. The base is only written once, but you have two exponents still. Then you multiply your exponents. So this would be negative 2 to the 15th power. So that's what that one means. And then you have the power of a product property, just means it's kind of like the distributive property in a way. If you have some stuff that is multiplied together, 4z to the 3rd power, that is the same thing. You could break it apart. You call it 4 to the 3rd times z to the 3rd. That'll be okay doke if you need to. And all these work backwards too. If you see two things that have the same power multiplied together, you could push them together and just raise it to that power. So you could work this both ways, right? And last but not least, I used this one earlier. This is the power of a quotient. That just means that if you have, I think I had 2/3, I think I had it to like a power, like, I don't know, 4 or something, you would distribute that. You'd have 2 to the 4th, 3 to the 4th, or again, other way around, right? If you had something that had the same power and it was division, you could divide it and have that power on the outside. But it only works if they have the same power. All right, with all those properties, let's see what I got for you here on examples 3 and 4. All right, example 3. Simplify each of these and try to assume all variables are non-zero. That's just something math geeks say. All right, so we got, really, when you see this problem, don't look at that. When you see this, you got 3 times z to the 7th times a negative 4 times a z squared. So if you see it that way, it's a lot more helpful if I break it down into each part. Then you're just multiplying together, so everybody just gets crammed together. So this is very simple. A 3 and a 4 multiplied together is a negative 12. And a z and a z, oh my gosh, they have the same base, so that's a z. And let's add their exponents, a 9th power, and life is good. So there would be my answer for A. For B, you can see that I have a 3rd power. I'm going to distribute that. So I would have y cubed. I'd have z. Now that's a power to a power. So you're going to multiply z to the 9th all over z to the, oh my goodness, 15th. Right? And now I can clean that up because I have a z on top and a z on the bottom. I can subtract those. So I still have y cubed, but I have z to the 9 minus 15. So what is that? Y cubed z to the negative 6th. Or since that negative exponent is there, let's move it down. Let's leave the y cubed on top and move z down to the bottom. And you can see there's your beautiful fractional answer. All right, example 4 in the last melon. It's just showing you how with really big numbers, or in that case, really small numbers, scientific notation. Again, what is 4.5 times 10 to the negative 5? That just means that you would take the 4.5 that we have, and I would move the decimal 5 spots to the left. So 1, 2, 3, 4, 5. That's the decimal. So it's a really, really tiny number. No one wants to deal with those really tiny numbers, so they use scientific notation. Now, for this problem, I have 4.5 times 10 to the negative 5th over 1.5 times 10 to the 6th. All I have to do here is figure out what the division part is. Why my pen is acting up, I have no idea. Figure out what that division part is so crazily. And in this case, I believe it's 3. And then I can deal with the exponents. Times 10 to what power? Well, if you have the same base, you subtract those powers. So what is that? A negative 5 minus a 6? That's a negative 11th power. And so there would be your answer. Now, sometimes you got to make sure that that decimal, the scientific notation, remember the decimal comes after the first digit. So this would be 3.0 if you like. And that looks pretty darn good. All right, last but not least, I have multiplication. So multiplication, same kind of boat. You just have to sit here and multiply the two numbers together. So if I were to do that, I would want to go, all right, 2.6 times 8.5, which I'm grabbing a calculator and looking at right now is 22.1. So 22.1 times 10. Now remember, same base, add those exponents. So that is also 10 to the 11th power. Now there's only one bad thing here. Scientific notation needs to be a number and then a decimal, and then you can have whatever numbers you need. So this needs to be this needs to be 2.21, not 22.1. So this needs to be 2.21 times 10. Now figure out what that happens to this exponent. If this decimal had to be moved 11 spots that way, I just moved it over one more spot, so now it's got to be moved 12 spots that way to be the same number, but written correctly in scientific notation. All right, that's it. Have a great day. Stay happy, and I'll see you tomorrow.